So the highlighted ones are ones that she wanted us to focus on.
Okay.
So the ones
Hold
that
on.
were
Hold on one
highlighted.
second. Let me open up my Windows Journal thing. So, to which sets of number does each number belong? Well, I assume the answers they're looking for here are for 4. That would be all real numbers. It would be all integers. It would be all positive integers. It would be rational numbers. You get where I'm going?
Right, and then natural numbers. And
Well, I don't know all of the different sets that exist, but I know the ones that I mentioned. Let's outline them. So we have real numbers. We have integers, which are whole numbers. We have positive integers. We have rational numbers. What other categories can you think of?
there's whole numbers. Did you put that?
It's the same as integers.
Oh, they are?
Uh-huh. In other words, that 4 is a whole number. It's also an integer.
We were told whole numbers were numbers that, like, had a 0 in it. And then...
No. Whole numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 11, minus 12.
Okay.
So, unless you can think of another type of set, we'll go with these 4 sets, and let's classify each of these. So the number 4 goes into all 4 of these.
Right.
Let's
irrational. I know it doesn't fit with irrational, but...
Irrational numbers. Very good. So this one is in the first 4. How about the second one?
So when it's asking for the square root of 6, are you supposed to square root it, or what exactly?
Yes. The key thing is the square root of 6 is an irrational number. All square roots that don't produce perfect squares are irrational numbers. In other words, square root of 2 is irrational, square root of 3 is irrational, square root of 4 is not. That's equal to 2.
Right.
So if you can't change if you can't get rid of the square root sign, then it's irrational.
Okay.
So square root of 6 would certainly be real. It's not an integer. It is positive. Let's change this category to positive, not integers, because there's the set of positive numbers and there's the set of negative numbers.
Right, and that's what I was saying, like natural numbers.
Okay.
We should put in our thing where natural numbers are counting numbers, like 1, 2, 3, 4, etc. Whole numbers are natural numbers and 0. So 0, 1, 2, 3, 4.
Okay, that's fine. Okay. So let's see, and square root of 6 belongs also to irrational numbers. Okay, let's look at pi. Is it real?
Pi always irrational?
It's real. Let's start from the top. There's real and there's complex. Complex involve imaginary numbers.
Right. She said we weren't going to get into those. She told us about
Right, but that's the 2 categories, is real and complex. And all of these are going to be real.
Right.
So they all fit in that set.
All right. When do you get into complex numbers?
As soon as you take the square root of negative numbers, that's equal to I. Square root of -1 is equal to I.
Okay.
Okay. Probably you won't get into it until Algebra 2. The last parts of Algebra 2. Maybe not even until pre-calc. And pre-calc is where you really get into it.
Okay.
Okay, so pi is part of positive numbers. And is it irrational or rational?
Irrational.
Okay, and the definition of rational is we need to be able to express it as a fraction. Irrational, we cannot express as a fraction. There's no way to express pi as a fraction.
Right.
There's no way to express square root of 2 as a fraction. You can approximate it, but you can't accurately express it as a fraction. All right, how about number 4, -6? It's real. All of these are going to be real.
Right.
Is it an integer or a whole number? Or both?
Okay. Both.
Okay. It's negative, not positive, so it would be the part of the set of negative numbers. What is 0? Is 0 part of the positive or negatives?
Neither.
Exactly. There's another category, even and odd. In other words, and there's prime and non-prime. So without telling us what sets they're referring to, we don't really know. There's all kinds of sets in mathematics. But, okay, so let's look at 0. 0 is even. However, it is not a positive or negative number. It is an integer. Well, or as your teacher says, it's a whole number. And it's rational.
Okay.
Let's look at this one. This line over the 0.6 means it repeats. That means it's 0.6666666.
Right.
It's real.
Real.
It's neither even nor odd.
Okay.
It's not an integer. It's positive. Is it rational or irrational?
It'd be irrational because it repeats on and on.
Actually, I can express this perfectly as a fraction. In other words, 2/3 is 0.666666 with a line over the last, meaning that if I carried it out enough places, it would all be sixes. And that's exactly what 2/3 is. So that's actually a rational number.
Alrighty.
Remember the definition. We have to be able to express it as a fraction. How about this? What is negative square root of 0.04? Let's simplify that first of all. What's the square root of 0.04?
Oh, let me do that real quick. 0.2.
Okay. Maintains its negative sign. So that's really what we're looking at. Certainly real. It's neither even nor odd. It's not an integer or a whole number. It's negative. Rational or irrational?
Rational.
Because you can express that as -1/5. That is exactly the same as that.
Okay.
Okay? It's not an approximation. About the square root of 0.4.
So it's a real number. It's not even or odd. It's not an integer. It's not positive or negative, and it
It's
is
actually
real.
positive. It is positive. Just like the last one was negative because of this negative sign there. This is positive. No matter what that square root is, it's going to be positive.
Okay.
Okay?
So it's positive and it is not a rational number?
It is an irrational number. And the reason I know is because 4/10 could be expressed like this, which is the square root of 4 over the square root of 10, which is 2 over the square root of 10. That's irrational because square root of 10 is irrational. Square root of 10 is square root of 5 times square root of 2, both of which are prime. And when you take the square root, like I said, if you take the square root of a number and it doesn't simplify to a whole positive number, then it's irrational. It's as simple as that. Okay? Different than 0.04. Notice that this was rational, this was irrational.
Right.
So you can't always tell by just looking at them. Replace each blank with the symbol less than, greater than, or equal.
We really don't need to do this. Like, I know that -7 is greater than -9.
Okay?
Because it's closer to 0. I know all of that, so.
Okay, but tell me where you want to go next.
Down to the next set of problems.
25?
No, that's the same thing except with fractions and decimals.
Okay, the fractions could be worth reviewing. Let's just do 25.
Alright. -1/4. Okay, they're both negative. -1/4 is greater than -1/3.
See what I'm doing here?
Yeah.
-1/4 is smaller. Excuse me. You're absolutely right. It's to the right of -1/3. Since it's to the right of -1/3, it's greater than.
Right, isn't that what I said?
Yes, it is. I made a mistake when I looked at it. Okay. I'm sure you have no problem with that one or that one. 31.
Alright. What does 31 say? -4 to the square root of 4. It would be -4 is less than negative. Oh no.
No,
Yeah.
you're correct. You're correct.
Yeah.
How about
-4
30?
is less than negative.
How about 33?
33. I'm gonna have to do that one real quick.
No, you don't really have to do any math to do that.
It's just what it looks like then, so
Yes, it's exactly what it looks like. In other words, if you remove the radical sign, it's the same thing.
okay, so -3 is greater than, greater than -5.
Correct, which means negative square root of 3 is also greater than negative square root of 5.
Okay.
Okay. Wow, these are some different kind of problems, aren't they?
Well, we switched in from geometry to algebra for review.
Uh-huh.
We're doing this for the rest of the year until the final, and then...
Well, that's good. That's good.
You know, it's weird, because I can't do geometry. It just doesn't connect right with my brain.
Uh-huh.
And then when we switch to this, I'm the first one getting it done, getting it checked off. All my homework is right. And then that's why I had to cancel on Monday.
Probably a little like me. I was really good at two-dimensional geometry, but as soon as I got into three-dimensional geometry, I wasn't good with spatial relationships.
Yeah.
And so I had problems with three-dimensional geometry. I'm fine with two-dimensional, but maybe something similar is going on with you. So what's the opposite of this number?
Opposite. Negative?
Yeah, it's a weird term to use. I don't particularly like it. I have actually students that come in, and when they're talking about this, they say opposite 2 instead of negative 2.
Huh.
Excuse me.
Bless you. Bless you.
Boy, my allergies have been kicking up all day. Okay, so negative is the opposite. What's the reciprocal of this?
I don't know.
Well, first of all, we need to put it into an improper fraction. This is a proper fraction. What's the improper fraction? How many total fifths is this?
8 times 3, 24 fifths?
No, it's 5 times 3, which is 15, plus 3, 18.
Okay. I did 5 plus 3 times 3.
Okay, it's 5 times the 3. In other words, I can write the 3 as 15 fifths, right?
Right.
That's the same as 3 plus 3 fifths. That's 18 fifths.
All right.
Okay. What's the reciprocal of 18 fifths?
Negative. Oh no. 5/18.
Very good. Reciprocal is just flip them.
Okay.
Okay. $37. What's the opposite of 7 halves? Negative 7 halves.
Positive 7 halves.
Okay. The opposite part's going to be pretty easy on these. You just change the sign. What's the reciprocal of it?
2 sevenths.
Negative 2 sevenths. You must carry forward the sign when you do the reciprocals.
Right.
Okay.
Okay, so when it says opposite and reciprocal, so once you do the opposite, you leave it that way.
There are two different answers. One answer is the opposite, the other is the reciprocal.
Okay.
So what's the opposite of 2 pi?
Negative 2 pi.
Correct. And what is the reciprocal of 2 pi?
1 over 2 pi.
Okay. Simplify each expression. Absolute value of 10.3. What are they looking for here? I guess, what is that? In other words, what they want us to do is to eliminate the absolute value sign.
So is it just 10.3?
What's the next one?
It'd just be negative 0.06.
Okay, what's the next one?
Sorry about that. My mom's calling.
Be careful on this one.
Positive 25.
No. That's why I said be careful.
What would it be then if it's not positive?
Well, let's do it step by step. To eliminate this part of it, what's that equal to?
Negative 25.
No. Absolute value of negative 25 is 25.
Oh, because it's the closest way to get to...
It's absolute value is always a positive number. It's like the absolute value of negative 0.06 is 0.06.
All right.
So the absolute value of negative 25 is 25, but we still have this negative sign over there. So the answer is that.
Okay.
Okay. What's 51?
8 plus 8.2. Is there an 8?
Well, first of all, do it one step at a time. Eliminate the absolute value.
All right, so it's 8.
No. Well, okay, it's 0.2 times what?
8.
What's that?
4.
1.6.
Okay.
When you multiply 0.2 times 8, it has to be a 1/6 because 2 times 8 is 1/6. And the decimal point goes right there. So
Okay.
that's simplified. Let's go down and look at 52. It's the absolute value of negative 1/3.
Positive 1/3.
Correct? What's the absolute value of 7 minus 10?
3. Yeah, positive 3.
What's the absolute value of 10 minus 7?
3 still.
Okay, what's the absolute value of 5 minus the absolute value of minus 7?
That would become 7. 5 minus 7 is negative 2.
Good. All right. Order of operations. It's been a while since I've done order of operations. PEMDAS. Are you familiar with PEMDAS? It means parentheses,
Oh, a little bit.
exponential, multiplication, division, addition, subtraction. So that's the order we always want to go.
All right.
So for 104, there's no parentheses, there's no exponentials, there's no multiplication, but there's a division. Let's do the divisions first.
All right. Is that 3 divided by 4? All right. And that's divided by 6?
And plus 6 divided by 4. So
Okay.
what's 3/4 plus 6/4?
9/4.
9/4.
That's the answer.
Okay.
105.
Let me see that here. So 2 plus, is that a plus or a divide?
It's a plus. And when you have multiple parentheses, in other words, these are called nested, where you have a set of parentheses inside a set of brackets or other parentheses,
Yeah.
always work from the inside out. In other words, you want to do the inside parentheses first. So the first step is changing that 2 plus 5 to a 7.
Right.
Divided by 3. So that becomes 5 times 7/3. And whether multiplication or division takes place, I think those are interchangeable, just like addition and subtraction.
Okay.
So, in other words, once I get it down to multiplication and division, that's 35/3.
Okay. So you don't multiply the
You
denominator?
do. There's an implied 1 under the 5. And I multiply numerators and I multiply denominators.
Okay, so there's no cross multiplication?
No, that's only in an equation. Oh. In other words, the only time you're ever going to cross multiply is if you have something like this.
Okay.
Where I have an equation, that's vital, and cross multiplication is merely multiplying one side by this denominator and then multiplying both sides by this denominator. So when I cross multiply these, I get 6x minus 1 equals 5x. In other words, I do two steps in one. But you're only doing that in equations. You never cross multiply unless you have an equation that you're dealing with. Okay. I don't really like these kind of problems because once you get into math, you never ever have these problems. There are not, people who write math expressions are very explicit about how the order of operations are to be done. So you just don't have these, you never see anything that's expressed like this. That's what I'm trying to say. Not explaining it very good, but
okay.
So what are you going to do first here?
5 times 2.
Okay. So what's the numerator going to be?
18.
In other words, we don't do the division first, huh?
Would it technically be right if you left it as 18/12?
Yeah. Just not simplified. And they say simplify each expression. So 18/12s wouldn't be fully simplified.
All right.
But their main thing here is to make sure you do the PEMDAS. Okay, so what's the first thing I'm going to do here?
The parentheses and then, so 40.
Well, here's a case where you actually do the exponential before you do the parentheses. You can do this parentheses first. There's nothing wrong with that. So 40 plus 24 is 64 divided by 8 minus, in this case I want to do the 2 squared first.
4 minus 1.
So now I have 64 divided by 8 minus 3.
So then
So
we get
now what? Right. In other words, we do this first to get 8. 8 minus 3 is equal to 5.
Right.
Okay. And there's only these last two. So on 108, what am I going to do first?
The exponent.
Yeah, exponential. So let me write it up to that. Minus 2 squared, which is 4, minus 1.
And then you're doing 24 divided by 8.
Okay, so now it's 40 plus 3 minus 4 minus 1.
And then it's 43 minus 4, so 38 is your answer.
Okay. Now you are good with math. That's a good talent to have. Okay, 109 is real similar to 108, only it's got a couple differences to it. So what's the first thing I'm going to do?
The parentheses, so 8 minus 4. I did the calculation. So divided by 4 minus 1. So then just do it 64 minus 4.
Actually do the division next.
Sorry, I thought that was a minus sign.
That's a 6.
Right.
So now it's 40 plus 6 minus 1.
Alright, so 45 is your answer.
Yeah. Okay. That wasn't bad. Well, I think it's always a good idea to do that, to review this kind of stuff.
Yeah.
Sometimes you can
They
go
like,
a couple of years before you get back into reviewing this stuff, and then you go to take your SAT or ACT test, and it's been 2 or 3 years since you've had PEMDAS. So, oh, here's the different sets of numbers. We have natural, whole, integers, rational, and irrational. Okay, this is the part I didn't see before. All right.
right, that's what I was saying that she wrote down.
Yes, yes, yes.
So if we can get one more in, it's if you go back just to calendar.
Hit the back arrow.
Yeah, it should do it. Or, yeah.
Oh yeah, that was property of real numbers. So we want to go to algebraic expressions now.
Yep.
The top or the bottom?
The very bottom.
Well, that's why I didn't see any of those others, because I couldn't read them until I had blown them up.
Right.
Oops.
So these ones are fairly easy and
Mm-hmm. Okay.
so the way I like to do this that she said I shouldn't, I wanted to ask you about this.
Okay.
Is before plugging in the numbers like a equals -5, I like to add them all up like 4 plus 7 is 11 minus 2.
Okay.
So
You can't add the 4A and the 7B.
oh, I'm sorry, I thought that was an A.
But you can absolutely do what you want to do. Combine all the A's, combine all the B's, and it'll make a much simpler expression to evaluate. So you're absolutely right. How many total A's do we have?
A's, it looks like 7 A's.
Plus this 2 over here.
Oh. Yeah.
How many B's do we have?
Just 5. Yeah, I think I see all of them there, 5.
Now it's actually less chance for making mathematical mistakes, although I suppose you could always argue that, well, maybe you made the mathematical mistake in combining them, but I personally like this technique.
Well, when she saw me doing it in class, she said I wasn't allowed to do that.
Well, maybe she saw you adding 4A to 7B. You're not allowed to do that. You can only add apples to apples. You can't add bananas to apples.
Right, it just looked blurry on my screen. That's why I said it.
Okay.
So.
Okay. Yeah, no, there's nothing wrong with doing that at all.
All right, awesome.
Let's see. We want to go down and find all the yellow ones.
Yep.
Okay. Well, we can't combine anything here. So tell me what to write.
All right. 12A squared. Yeah, since we can't combine anything, so it'd be 12 times -5 squared minus.
And I think it helps to write the whole thing out before you do any math.
Okay. So then minus 3 times -5 times -4.
Now the only thing you have to be careful with when you do this is to make sure you don't interpret these negative signs as subtraction.
Okay.
Okay? So be very careful.
I was wrong.
Be very careful the way you write it. And B was not -4, it was +4.
Right, that's what I meant.
Okay, so there's our expression. And I definitely think you should write it fully out before you go to evaluate it. So now we'll evaluate it. What's this become?
-60 squared.
What's negative 5 squared? Let's do it one piece at a time.
25.
Okay. What's 3 times negative 5 times positive 4?
3 times negative 5, 15 times negative 4, 60.
It's negative 60.
Right, sorry.
Because I'm looking at just this part of it here.
Right.
There's only one negative sign in there. So I'm going to subtract a negative 60 and then plus 8. So 12 times 25, if you have 12 quarters in your pocket, you have $3. Plus 60 plus 8.
Right.
Okay. Okay, do this however you want. How do you want to do this? I'll start with what they've given us.
So it's negative 4y minus 6.
Hold on. Where are you getting the negative 4y? If you want to combine like terms before you substitute, which I think is fine, make sure you do it properly. In other words, our first goal is to get rid of the parentheses. What do I have when I get rid of the parentheses?
Don't you distribute the negative sign, though, don't you?
Yes. Right.
So negative 4y minus 6x.
Okay. And now combine the first two.
So we got negative y and then minus 6.
Minus 6x, okay. So there's our expression.
Minus negative, alright. So negative 2 minus 18.
Hold on.
Negative 18.
It's a negative 2. In other words, if we're going to substitute for y, we have to substitute negative 2 for it.
Right.
Which makes it a negative 2. Minus, in other words, what I'm suggesting here is don't take any shortcuts. The moment you start taking shortcuts, you're going to lose a negative sign. When you substitute precisely like that.
Okay.
Now, you can't make any mistakes because a negative 2 is a positive 2 minus 18, which is?
Negative 2 minus 18 is negative 20.
Negative 16. It's not a negative 2. It's a 2 minus 18. Notice that this was a negative 2, which turned it into a positive 2.
All right.
Okay?
All right.
Now, let's just, for the heck of it, go back to the unsimplified equation and substitute and see if it makes any difference to you. You may find it easier doing it this way. Okay, so in other words, if I don't simplify first, this is what I have. Well, this is negative 6 minus, and then if I do everything in the parentheses, I have a minus 8 plus an 18, which is plus 10. So now I have a minus 6 minus a 10, which is negative 16. So I get the same answer, which obviously you're going to. I don't know. Whichever one leaves the least chance to make arithmetic errors is the method you want to do.
Right.
In fact, that's always the case in math. No matter what you're doing, if you have a couple of different methods of doing it, always choose the one that gives the least likelihood of errors. Which means if you have a choice, always work with small numbers, not big numbers.
Right.
If I'm doing this kind of math, I'm not going to multiply 35 by 35. I'm going to first cancel that 7 with that 35, making that numerator 5, and now I have to multiply 5 times 35 and divide the whole thing by 6. But always make numbers smaller when you have a chance to. So, number 7.
All right, so we got negative 5x plus negative 10y.
Okay, so we're going to simplify first. That's minus 10y. In other words, you don't want to simplify if you can't do it perfectly, because it's going to cause you to get a mistake. This negative sign has to be distributed to both of these terms.
Right. Isn't plus negative 10 the same thing as that?
Okay, yeah, but you don't ever say it like that.
All right.
In other words, if we're going to reduce this expression, it's minus 5 times x plus minus 5. Okay, I see what you were doing. Okay, all right. What's the rest of it?
Plus 15x plus 30y.
Okay, now let's simplify that. Starting with the x's.
So we got 10x plus 20y.
Okay. And then let's evaluate it.
70 plus negative or minus, and that would be negative 140, right?
Uh-huh.
Okay.
All right. What's 21?
That would just come to 4a.
Okay, what's 23?
Negative 5a minus 5. Oh, wait. Oh, I'm sorry. Negative a plus b.
What's negative 5a, negative 4a?
9a.
Negative 9a. That's what 23 answer is.
Right.
Okay. 25?
That's 5 or 10r plus 5s.
Okay. 27?
2x squared plus x.
29?
Minus 0.5x.
Good. 31?
10y minus 4 plus x.
Okay. 33?
Negative, yeah, okay. Negative 3a plus 8b plus 7b. So combine those and you get 15b minus 3a.
Okay. 35?
Negative 3x plus 4y minus z.
Okay, good. 37, let me write it as you're saying it.
Would that be 4a squared minus 8?
No. Perimeter is we're going to add up all the sides.
Okay, so just 4a minus 8b.
That handles that side, that side, that side, and that side. In other words, you took a minus 2b and multiply it because there's 4 of them. What else do we have?
All those b's, so
How many of them are there?
4 b's on each side, so 8 b's total.
So what's
16.
this perimeter?
4a minus 16b.
Okay, these cancel.
They cancel?
Uh-huh.
Why do they cancel?
Well, because we had 4a minus 8b plus 8b.
Oh, okay.
Remember, each of these is a minus 2b, so when we multiplied that by 4, we got 4a minus 8b.
Okay.
All right.
I see that now.
Okay, that's all of that. Should we go to solving equations?
I guess if we want to, I'm going to grab my own sheet of paper. I have a very hard time seeing this.
Okay. We only have 10 more minutes.
One minute here. Alright.
Okay. So let's start with 7w plus 2 equals 3w plus 94.
Alright. Let me write that one down real quick. 7w plus 2 equals 3w plus 94. So subtract 2w from each. So then
Okay, hold on. How many w from each?
I'm sorry, just subtract 2 from each side.
Okay.
And then subtract 3w from 7w to get 4w equals 92. And then just divide by 4. Comes to 23, yeah.
Okay. About the second one. What's the next line? Well, here, I'll write it out. Read the next line to me. And I might add that at some point you can do both of these steps kind of at once. The way I like to think of this is I'm going to put everything with a variable in it on one side and everything that's just numbers on the other. And just for comfort, I like to keep my variables on the left side and my numbers on the right. So if that helps you, fine. It's not necessary. You can solve equations with the variables on the right and the numbers on the left. Sometimes it's actually easier because it keeps everything positive, like in this case here. Notice that if I move my negative 3d to the right, I get 4d, and if I move my 9 to the left, I get 34. So I would have this. But that's fine. Then D is equal to 34 divided by 4. But the way I would be more likely to solve it was I want to keep my variables on the left, so I'm going to move this D over. So I'm going to have minus 4D equals 9 minus 43, which is minus 34. So I still get the same answer.
Okay.
Just as whatever you're comfortable with. I think one of the secrets to math is once you find a methodology to use, stick with it and don't switch it around, because there's always 3 or 4 different ways to do something.
All right.
So tell me the next line on number 5, so I don't have to rewrite this line.
Okay.
Do it all in one step. Move the variables over and the constants over in one step. What's the next line?
Okay, so it'd be 2A equals 7.
Okay. And number 7.
I can't see that.
I know. Hold on. I was trying to get it so you could. I just have a hard time with my cursor. It doesn't behave as nicely as my mouse does. Here, let's do it this way. Okay, number 7. What's the next line?
Next line here, we're gonna. So it is 3C equals.
No.
Oh, I'm sorry, 7C. 7C equals 17.
Okay. Number 9. What's the next line?
Let me distribute that. 6N.
Yeah, and that's fine to take 2 steps on this. That's the next line. Now what's the next line after that?
So then it's 3N equals 24.
Okay, number 9. What's the next line?
Number 9?
Oh, that's what we just did. Hold on.
Yeah.
Move this down a little bit. Number 11. What's the next line?
10 minus 5G equals 0.
And the next line?
So negative 5G equals negative 10.
Okay. And the last line?
4K plus...
Hold it. We need the last line of this equation.
Oh, sorry, 2.
Okay. And that was 11. Okay, let's do 13.
6T minus 12 equals 18T minus 4.
Okay, and the next line, do both steps in once.
12, so that is, hold on, 24T equals 8.
We got 6T minus 18T.
Okay, so,
remember that if you move something to the other side, you have to change its sign.
all right.
So it's going to be 6T minus 18T. So, and then what's the number on the other side?
And then it's 8.
All right.
Negative 8.
No.
Oh, I'm sorry. Yeah, regular 8.
Positive 8. Okay. Number 15.
4K plus 20 equals 18K minus 8.
Next line.
Next line, it's going to be negative 12k equals...
14.
Oh, sorry.
Okay.
Negative 14k equals 12.
Minus 28. In other words, you can't take plus 20 and minus 8 and come up with
Right,
12.
I'm just thinking of it wrong.
You have to think of this as you're moving this 20 to the other side. It's going to become negative. So now you're going to have a negative 20 plus a negative 8.
Right. I just see it weird in my head.
I know. I'm trying to get you to change that thinking. What I'd like you to think of is that rather than the way they teach it in school, which is let's subtract 20 from both sides. That certainly works. There's nothing wrong with it, but it's really kind of silly to have to write that because every time we write that, we know that's equal to 0. So the better way, quicker way to think about this is if I want to move this 20 to the other side, just change its sign. It becomes minus 20. If I want to move this 18k to the other side, make it negative 18k.
Right, it helps me see it. It's just easier for me to see it.
Okay. So 17. Oh, actually, you know, it's 4:30, and I do have a 4:30 today. So I'm going to have to run, Ryan.
Alrighty.
But that was pretty good. Yeah, that was a good practice session. It was very useful, I think. And you are good at that part. So I will talk to you next Monday
Alrighty, sounds
at
good.
3:30. Okay, bye-bye.